Good morning. How are you today? Did you go to the party last night? Yes. All right. Yeah, let's begin. So, my name is Álvaro Sánchez. I'm going to talk to you about Micronaut and GraalVM. Let me introduce myself for a moment. Like I said, my name is Álvaro. I'm coming from Madrid. As you can tell from my British accent, it's like pure English. I'm a Java developer. Been working always on Java. I'm working on Micronaut since the beginning. So we started the framework in 2017. I'm currently working on Oracle Labs or Oracle. So Oracle Labs is like a research and development organization for Oracle. Where, for example, GraalVM belongs to, Micronaut belongs to, and a few other projects. And I'm not a developer advocate myself, so I'm a committer on the project, but I enjoy going to conferences and speaking about that. Well, you have my Twitter X, whatever it's called, handle there, if you want to reach out. Slides are available on speaker deck in case you want to grab them. Now that I introduced myself, so would like to ask a few questions. So, who has heard about Micronaut before? Who has done something with Micronaut? Okay, good guys. Who's using Spring Boot today? Okay, keep hands raised. Keep them raised. Who's using Quarkus? Okay, so Spring and Quarkus people can leave the room now. No, it's a joke. It's a joke. I told you that I've been working on Micronaut since the beginning, but I will tell you a story. It's like a true story. At the beginning, we didn't name it Micronaut, where the original name was Particle. But we couldn't name it Particle because the main name was not available, and there was like another project with that name, so we had to choose like a new name. And so we ran like internally like a poll in the team to choose a new name. And I proposed a name that wasn't selected. I don't understand why. So my proposal was to name the framework Summer framework, and you will say why? Because summer is better than spring. It's a joke. Okay, let's begin. Who's totally new to Micronaut? Yeah, this is the place for you. So there's 3 ideas I would like you to get out of this presentation and about Micronaut. So one is that Micronaut is a modern Java framework. By modern, I mean that it's not created like 20 years ago, like your traditional Java framework. So we created thinking of the type of applications that are written today. So that's microservices, that's serverless, or functions, etc., or message-driven applications, right? That's the focus. We're no longer creating Word files. We're no longer creating that kind of applications, right? It's a general-purpose framework. So people typically use it for like REST APIs. That's the typical use case. But you can create command line applications, or you can create serverless functions. You can create like a message, like a Kafka producer or a Kafka consumer, which doesn't have a REST API whatsoever, right? So it's general purpose. And is highly optimized. Performance is one of the design goals of the framework, and I will tell you how we achieve that. We use a technique which is becoming like more popular now, called AOT, ahead of time computation. So the idea is that we produce all the framework infrastructure at build time. Unlike, for example, other frameworks like Spring or Jakarta IE, who do this, like most of the framework job is happening at runtime, right? So when you have like in Spring, you have like auto-wired or add service in a class. Spring will have to, for example, to do like the dependency injection, we'll have to use normally reflection to set the field, and then if, for example, you're using Spring Data JPA, you have like an interface, it will generate dynamically a proxy which implements the interface, and will do that at runtime, but it will also like traverse your jar files, your classes. It will traverse, it will scan essentially all your class path, searching for annotations. It will search every single class, every single member, every single method, searching for annotations, and that takes time, right? We don't do any of that at runtime. What we do instead is we react to the annotations using Java compiler API, which is called APT, Annotation Processing Tool. And with APT, we're able to, for example, when you're using add-inject, which is the standard way of using like dependency injection from the Jakarta namespace, we generate the corresponding code at compile time. So at runtime, there's no reflection. Reflection is slow, and because it's slow, normally frameworks will have like reflection caches. But then it's funny because Spring will have its own reflection cache, but also like, for example, Hibernate will have their own reflection cache. And that's basically memory consumption. And also, for example, if you think about the number of bins that you have in your application, the larger amount of bins you have, the slower the application will start in those frameworks, because they will essentially scan everything. So we don't use reflection, we don't generate proxies, there's no dynamic class loading, and we don't scan your class path. It's a general purpose framework. You can use it with Java, Kotlin, or Groovy, maybe on Gradle, and basically any cloud. We started in 2017, and so it's been like few years now. Today we are at version 4. I will do like a quick overview of the features. So the core of the framework is dependency injection. You can use like JSR 330 annotations, like add inject, add singleton, etc. Or you can even use Spring annotations. And for example, if you think about the other parts of the framework, like for example the HTTP server that we will see later, we have our own annotations for like add get, add post, etc. But you can also use Spring MVC, or you can use JAX-RS. And it will work all the same because we have the ability at compile time to map from those annotations to the Micronaut internal ones, right? So there is even the possibility to, for example, take a system Spring Boot application and add the Micronaut annotation processor, the Micronaut runtime dependency, and run the application as a Micronaut application, but with a Spring source code. If you're interested in this, I can like explain it later. Yes, in terms of configuration, well, all popular formats are supported, so YAML, properties, etc. In Micronaut 4, we changed the default to be properties instead of YAML, because YAML is essentially a kind of worms. It will make your application to start slower, consume memory, so not everybody needs YAML. But if you want it, you can use it, but the default is properties. We have a validation engine, which is built-in, comes by default. It's reflection-free, is faster, and consumes less memory than Hibernate validation. But if you need like full Beam validation MPA compliance, you can use Hibernate validation. That's an option. We have also an AOP framework, again, compile time and reflection free. This will be like a hello world. So as you can tell, we use an annotation programming model similar to Spring or even to Quarkus, if you like. So nothing special here. But we also have some like built-in goodies that you can use. For example, declarative client. This is like, for example, in Spring you will have to use Spring Cloud OpenFame, I think it's called. The difference is that this HTTP client will be generated at compile time, right? For messaging applications, all the major technologies are supported, with also annotations and building blocks to create messaging applications. In terms of that data, there is like one part of the framework, we call it Micronaut Data, which has support for like the major SQL and NoSQL technologies. It builds on the repository pattern. So who's created like a Spring data repository before, right? It's the same idea. But again, the difference is that this is an interface, and the implementation will be generated at compile time. Also, the query will be generated at compile time, and we do few things at compile time that will make your life easier. Like for example, this is if you see this method name, right? It's find by name, order by name. And this is assuming there is like a user entity that has a name property. If you were to have like a typo on the method name or any of the properties of the entity, or even the argument of the method, we will throw a compilation error. So we will check at compilation that what you're specifying is correct, as opposed to, for example, other frameworks where you will have like a runtime exception. And you can, like, there are like auto-generated methods. So there is this craft repository parent interface that will give you like a save, find one, update, etc., delete. And then if you need like custom queries, custom operations, you can even go down to the SQL or JPIQL or whatever you want. In terms of security, there's essentially support for the major technologies in security, so OAuth 2, JWT, OpenID Connect, etc. And there's much more things. Distributed tracing, service discovery, distributed configuration, monitoring, integration with test containers is really nice. We call it test resources, and you can essentially have test containers for development and testing out of the box. You don't even have to use the test container annotations or API. We'll figure it out, and we'll start the container for you before you run the application, and we'll stop it once the application stops, and also for the test. So we will start the container for you before the test, and we'll shut it down after. You can get started with like a website. There is a website called Micronaut launch.micronaut.io, and it's a web interface to generate a project skeleton. So you tell what the features that you want to use, the type of build that you want, Java version, blah blah blah, and we give you like a skeleton application. You can push it to GitHub from there directly, etc. If you're more like a terminal person, we have a CLI that you can download and use it. There is a IntelliJ Ultimate wizard and a Visual Studio Code extension as well. So those are like different ways or different frontends for the same backend for creating new applications. Yeah, like I told you before, we've released like Micronaut 4 recently. It's like the latest major version of the framework, and there are a few things that I would like to mention. One is that the baseline is now Java 17. So who is not using Java 17 in production yet? Yeah, very few. That's really impressive. I wouldn't expect that number. So yeah, so for those that are not on Java 17, you can always use Micronaut 3. Micronaut 3 will be supported for many years. But it's like in maintenance mode, right? So there's no, there will not be any feature development on Micronaut 3. Micronaut 4, you need to use Java 17 or higher. And that allows us to, first of all, internally, we were able to use the new language features internally across the framework, and that will essentially, reduce the code base and make it easier for us to maintain it. But it also allows us to, for example, support built threads. We have like a new client implementation based on the new HTTP client from the JDK. Etc. We also support the latest Kotlin and Groovy versions for GraalVM. Well, there are many improvements regarding GraalVM, but it's basically now faster and consumes less memory. New version of Micronaut Data supports Hibernate 6 and Hibernate Reactive. In general, the idea of the release with Micronaut 4 is to be like a smaller, even smaller, faster runtime. So now we have the performance close to raw Netty. So Micronaut, the HTTP stack of Micronaut is based on Netty. Netty is essentially like a networking framework that all the Java frameworks use, basically for the communication layer. So we get like a performance close to raw Netty. So the Micronaut overhead is almost nothing. We made a few dependencies optional, and yeah, that's basically it. There's like a few noticeable features worth to mention. One is an expression language. So we have introduced an expression language similar to Spring Spell, but again, this is all compile time and is checked at compile time. So, for example, in this, this is essentially a string that you're passing to like the typical scheduling annotation to schedule jobs. And this JC variable is basically this parameter that you're using here. So if you were to make a typo in either of those places, it will not compile. And it can be used, for example, for security. Although this is like a very basic implementation, but you get the idea. We also have like bin mappers. So this is an alternative to map struct, but again is like built-in, type safe, compile time, etc. The idea is to have like annotations. So you have like an interface and you have annotations to say how to convert from one class to another. It's like the typical use case when you have like a DTO and an entity and you want to convert back and forth. You simply specify this interface and we will generate it. And there is something called the control panel. Well, I think the resolution is great, but essentially this is a development UI for getting insights about the application. You can see, for example, which are the configuration properties and their values and where are they coming from. You can have a look at all the bins that have been loaded and their dependencies, and you can, for example, change the login while the application is running, or reconfigure loggers, etc. But this is like essentially for development. So far so good. Yeah, blink if you. Yeah, thank you. It's too early, I understand. So, Graal Cloud Native. Who's heard of Graal Cloud Native? Yeah, it's not GraalVM. I'm telling you. If you go to essentially graal.cloud, that website, Graal is now like an umbrella, or like an umbrella brand for 3 different projects. One is GraalVM, which is probably what you know about, and that I will explain later. Another one is Graal Cloud Native, and the third one is Graal OS, which is like a serverless platform. So Graal Cloud Native is essentially a Micronaut distribution built by Oracle. And well, it has like pre-configured configuration and modules to basically make your life easier if you want to deploy to the cloud, etc. But this is essentially Micronaut open source, but built by Oracle. And this is important because there are some companies who are not able to basically use a framework from Apen Central. They need provenance, and they need security scanning. So this is essentially what the Micronaut distribution of Oracle is doing. So you can check it out at graal.cloud. And then a final note about GraalVM. Who's used GraalVM before? Yes. Do you like it? Yes. That's the attitude. That's the attitude, yeah. What is GraalVM? Everybody knows GraalVM because of one component of GraalVM, which is native image. But GraalVM is an open JDK distribution. Simple as that. I use it as my default JDK locally. So it has Java, Java-C, Javadoc, all the JDK tools. You have them with GraalVM. But it also has a component called native image, which is able to generate a native binary from a Java application. So with GraalVM, you have 2 options. You can use it as your JDK, like any other distribution. And it will use JIT as any other OpenJDK. We'll use like a JIT compiler and garbage collector, blah, 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 everything. And then the other alternative is saying, okay, for production, I want to run my application not as a jar file, or not as like a Java JIT application, but as a native image. So with native image, you basically generate a binary. And what it will do, it will start from the main class of your application, and it will traverse all the reachable code from there, right? And it will essentially compile that code to native code, and will give you a binary which is dependent on the operating system where you're running this, right? So if you run it on a Mac, you get a Mac binary. Typically, you will do this on CI, so you build it on Linux and deploy to your Linux server. What you get when you do this is essentially a native binary that starts in a fraction of that of the Java counterpart, and the memory consumption is also a fraction of that. I will show you later. So the idea is, to have like a really fast startup. You will see the numbers later. Lower resource usage, so in terms of CPU and memory. Minimize vulnerability because the attack surface is reduced, because all code that is not reachable is removed from the native image. And compact packaging because it's a single binary you can distribute, and it has everything inside. Now, GraalVM is supported by all major frameworks in Java, but the combination of Micronaut and GraalVM is unique. So you will not find like a better integration with GraalVM. So you can get like a hello world starting in as low as 6 milliseconds, and I will have to update these numbers because, for example, with Apple Silicon, I think it's a bit less than that. they consume, I don't know, 12, 15, 18 megabytes of memory. That's the footprint, like the starting memory consumption. If you compare to regular Java, we're talking about 250 milliseconds startup time, which is impressive, but it's not 6, right? So 6 is it's magic, and all of this is not only without a performance overhead, but with a performance gain. So it's faster. It's incredibly fast. So use cases of GraalVM typically, so serverless functions. That's the typical use case of GraalVM. Because in a serverless function, you want to call the startup to be as low as possible, so that your functions are kept call and you're not build too much for the function. Another use case, for example, if you deploy to Kubernetes and you do rolling deployments and auto scaling, you want your pods to become, or your containers to become ready really quickly, so you can scale up and down really quickly. In terms of performance comparison, like for example, development startup time, this is milliseconds. By development startup, we mean, for example, there is like hot restart, so we will scan while you're running in development, we will scan for changes, and when you change the source file, we will restart the application. You can see Micronaut is the fastest out of the 4 major Java frameworks in both, like with packaging the application or not packaging the application. And with GraalVM, we also get like the lowest bar, which is this blue bar here. Those are statistics collected by Matt Rabel, which is a developer advocate at Okta, who is doing regularly this framework comparison. So the idea that I want to tell you is that basically we put a lot of focus on performance. We will do everything that we can to shave every millisecond that we can from the startup time, and the startup time matters a lot. If, for example, for testing, you will see that later. And also in terms of memory consumption, we have the best. There is a use case of Micronaut and GraalVM, which is the Disney Plus. Disney Plus is using Micronaut and GraalVM on AWS Lambda, and they have a lot of Lambda functions for certain services. So there is like a case study published by Amazon. So I recommend you to check it out. Okay, so let's get to the code. We have a few minutes. Let's hope the demo gods are with me today. So what I have here is like a regular Micronaut application. In this case, this is like a standard Maven project, no surprise. We have like a main application class, no surprise. You can run it from the IDE, you can run it from the command line using Maven, or you can package. There are multiple ways to run this. The only, like, this is like mostly a hello world. The only thing that I did before that is adding Flyway migrations to have some data ready for me to use. So, do you know what Flyway is? The database migration tool. So, I will create like an application to manage football teams. So there are a couple of migrations, one to create the table and other one to insert a couple of rows into the database. I'm using H2, like in-memory database. So far so good? Yeah? Okay, so let's create actually, let me use, because I have a cheat sheet over here, which I think is gonna be better. Yes. So first of all, I will create like the entity. In this case, it's gonna be like a record. We're gonna be calling it team. This is entity. I'm using JPA annotations, but I'm not gonna be using JPA. What this means? What this means is that in your source code, you are able to use JPA annotations, and we will use them to basically build, like for example, the queries and all that is necessary for this to work. But this is not using Hibernate or JPA at all. So it's only annotations. The other annotation that I need is startable. One of the new features of Micronaut 4 is Micronaut serialization. Micronaut serialization is a replacement of Jackson. Jackson is great. It will basically serialize and deserialize anything, but it's really slow. It will add a couple of megabytes to your heap, and not everybody needs that. So by default, in Micronaut 4, you get Micronaut serialization, which is built in, is compile time, reflection free, consumes less memory, and will add no overhead to your startup time. And then if you can use, for example, Jackson annotations. So Jackson annotations are supported, but once again, the runtime of that will be Micronaut serialization, because we are able to make this distinction between what's in the source code and what happens at runtime. So we process this during compile time. So this servable annotation from Micronaut serialization will essentially make Micronaut to generate what's necessary to serialize and deserialize this from and to JSON, and it will be generated at compile time. So here we're gonna have like at ID, generated value, long ID, and then string name, stadium, and that's it. Now the next thing I'm gonna be creating is the repository. So this is a theme repository. And this is an interface. This is a JDBC repository, and we need to specify the dialect. So in this case, it's gonna be S2. The reason we need to specify the dialect here in the notation is because the queries will be generated at compile time. So theoretically, for complex queries that are different, on Postgres than Oracle, the queries will be different. And in this case, we're extending an existing class, which is CRUD repository, and we need to specify the entity type, which is team, and the primary key type, which is long. And that's all that I need. I don't need anything else, because CRUD repository is already giving me basic operations like save, update, blah, blah, blah. So far, so good? Yes? Okay. Now, what else I'm going to be creating? I will create like a contract for the REST API. And I'm going to be calling this Team API. This is also going to be an interface. I will declare like a constant with a path, and then declare a couple of operations. One is iterable of team list, and the other one is HTTP response of a team get, and we pass long ID. And then this is a get operation, and this is also a get operation, which is mapped on the ID path parameter. The reason I'm using an interface is, well, I'll implement the controller and you'll see why. So team controller, and this is a class, and team controller is a controller on this path, and this guy implements the contract. We're going to be using the repository, so I'm going to be declaring like a private final team repository, and then a constructor. Constructor injection is the default, no need for annotations, no need for an inject or anything like that. Micronaut will figure out that it needs to give you like an instance of the team repository, so it's like implicit dependency injection. And then this is simply repository final, and this guy here is repository found by ID, I think it is. And then we map this to an OK response. Or else it's not found. Not found here. So you see, like, for example, when you return, like in your controller methods, you return like a POJO or a collection of a POJO. Micronaut will serialize that to JSON. But it's basically really smart on depending on the return type. So, for example, you could return like a flux of a team. You know what flux is from Reactor? Yes? So if you return a flux, Micronaut will subscribe to the flux, and once the results are emitted, will be sent to the client. And also you can wrap responses in an HTTP response, and this is useful for example, if you want to modify like the headers or any other than the body of the response or the status code. So in this case, I want to like return 200 or 404, depending on whether the team exists or not. And then we can write a test. So I have an empty test class here. There is like a Micronaut test annotation. With this annotation, you can easily, this will like essentially start the Micronaut application on a random port, and you can inject beans here and make requests to it. So if you remember, there is like a declarative client I would like to use, but I don't have such client. I would like to have like a client for my controller, but I can easily have one. And this is gonna be like a interface team client, stands team API, and this is client, and we use team API path. And with that, I have an HTTP client for my controller, as simple as that. And then in here, we can, for example, inject this team client, and I use @inject from the Jakarta namespace, and then we can say this list, and we can say client list and into this variable, and then we I can say assert equals respect to, and then we're going to be casting this list to a collection. And import class need like another parenthesis here, size, and close. And this is a test, and we can run it. And if the demo gods are with me, yay. I'll do it again, because it's 300 milliseconds for a functional test. So this testing experience will change your mind about whether you need to create millions of unit tests and fewer integration tests. Because writing integration or functional tests or whatever you call them is really easy. 300 milliseconds is including flyway migration. So it's starting the Micronaut applications. It's like a whole startup, and you will say, you're cheating. So I included in the logpack configuration a couple of loggers to prove that we're actually doing, well, you can see like the flyway migrations in here. And then we're sending HTTP request to this application on a random port. And we're doing a query, so it's using Micronaut Data JDBC, and this is the response, and it all took 300 milliseconds. Do you like it? Yes. And then the other thing that I'm going to show is the native image. So let me use this terminal here. No. Here is better. So I already generated the native image. It takes 1 minute, but I don't have that much time. So, so it's actually go to the solution. Oh, come on. I don't know what's going on with this terminal. So leave me alone, SDK man. So we have here this. Let me do it again, because if you blink, you miss it. It's 32 milliseconds. And including flyway and everything. And so I don't know if we have time for questions. One question. Let's do one question. In the meantime, there is like a feedback form for me. It's like a single star rating. I will really appreciate if you can let me know if you like this. Does anyone has any question?